Hi, I'm Paul Scott, Challenge 9 owner. The challenge brought is equipment failure rate analysis using maintenance data. Next slide. I was joined by two brave chaps. We call ourselves the Three Amigos. We are handsome, as you can see, and we hail from Jacob, Exodus, and Harbour Energy. The data included items such as work orders, equipment, cause and remedy, to identify when equipment may fail in the future and what insights can be drawn prior to it. Insights we hope to gain from it are, can we reduce maintenance costs, potentially identifying a problem before a failure, and using engineering comments to find insights. For example, slight corrosion versus heavy corrosion on failure could indicate that heavy corrosion is on the way. We would like to see an indicator for when equipment may fail and failure classification. The data was from 3 assets in Excel format, but prior to the challenge, there were 3 XML files, but these were removed due to anonymization concerns. The benefits include, but not limited to, predicting equipment failures and to give an opportunity to intervene before failure. In addition, better maintenance planning, less corrective maintenance, therefore reduced downtime and reduced maintenance costs. No cost data was provided, so this is an assumption.
So the challenges that we faced during this hack were that we had multiple data sets over multiple files, and they took a lot of time to get to grips with and also manipulate this in Power BI and Python. We also had some problems with missing data and inconsistencies in the data as well. Regarding our team, we had quite a small team and we were all fairly inexperienced in data science and coding. So I think we would have benefited from having a larger team with a wider skill set to improve the final solution, and also having a bit more better domain knowledge of the data set would have been beneficial. In terms of the tools used, we used Microsoft Teams and Mural for team collaboration, Power BI and Google Colab for data manipulation and visualizations, and Pandas was the main package that we used in Python for data handling. For the process, we made a parallel attempt to manipulate the data in Python and also Power BI. Both followed a very similar method. However, we had to abandon the Python approach quite early on as Google Colab was running out of memory due to the very large data sets. Martin will now talk you through the Power BI process, which was the actual process that we followed.
Okay, so in Power BI, we followed the data analysis process to collect, cleanse and model the data, which resulted in the following dashboard. So here you can see that we've got our failures by duration. So down the left-hand side of this chart, you can see we've got sort of 0 to 100% there, with a lower percentage, meaning that the equipment failed earlier. This percentage could be toggled using the filter in the top right-hand corner, which then allowed us to drill into any classifications along the bottom of the chart. Once you drill into those classifications, this takes you to a level with equipment. So you could see within the classification the equipment which was bringing down that percentage, which gives you an idea of what equipment was failing before others. Move on to commercial. In terms of the commercial applications and benefits, this data set that we had came from an industry standard application. So any insights could be shared, improving maintenance planning and efficiencies for everybody across the industry.
Future developments. During the investigation into the data to answer the problem statement, there were a number of routes that could be investigated, but due to the huge data set and the time available, we couldn't traverse all routes. I believe we only scratched the surface, but some more time would be invested into visualizations with additional data made available from the maintenance system. Model and manufacturer bring to mind. There was data that was taken out of the challenge. If it was available, we could use a natural language processing API. The GPT-3 OpenAI snippet below shows we investigate the concept on the comments, and this particular example shows grammar and spelling corrections with a potential breakdown of keywords helping classify failures. The sentiment analysis in the NLP in Python could be used to gauge the severity of the faults and would be of additional benefit in analysing the potential gravity of future issues. So the first question, what assumptions have you had to make to conduct your analysis? Every failure has to have cause and remedy, but the data did not support this. Potentially changing the process at the work order data entry stage will negate this assumption. this would be fed back to the maintenance manager through reviewing of the data to review data process and data entry. The second question, is there an opportunity to use machine learning to predict failure rate? Yes, we could use machine learning for future iterations. We have the date field, which allows us to create a duration. This could be tacked on to the last known fail versus current date of equipment to predict failure. We have a hierarchy of codes for the equipment, so that we can see the failure rate and when they failed on different classifications. And with additional comments being made available, we could use GPT-3 to expand on this challenge and include the results in the ML analysis. On the third question, what would I report back to Harbour? There were multiple rows of data with failures that resulted in no comments or code. There would need to be comments even without a language processor for the maintenance team to fully understand the issue rather than just a code. Also, multiple rows of causes, problems, and remedies didn't have an appropriate fail marker, and comments available had large variations in spelling or interpretation. For example, environment versus weather. Is it indoor, outdoor? It's very unclear.